Okay, well, we're talking about antimatter, so if you get confused, don't be surprised.
So basically, what antimatter is basically
Antimatter is a material that's created deep in the universe that pops into existence and pops out extremely quickly.
so antimatter. When you measure it or observe it in any way, you will see it's different from normal matter.
It's negative.
You see,
It's negative.
or positive. So matter has simple atoms. Okay, nuclei have neutrons and protons. Protons have a positive charge and electrons have a negative charge. Now antimatter switches that, just as in the name. So electrons will be called positrons, as having a positive charge, and the protons will be called apparently electrons or antiprotons. No, they're antiprotons.
Wow.
And there's a theory of the antiprotons being made up of something called antiquarks, which make up protons in the world, but antiquarks can make up antiprotons, which is nuclei. If you were to put these two pieces of matter together, you would create pure energy that could basically delete stuff.
Yes.
How to explain?
It'd be negative.
If you shot this table with a bullet-tipped and very light amount of antimatter, it would disappear.
We're starting, so.
So
You can re-explain it.
okay, well, ignore that. But if you shot the table with antimatter, it would disappear into a pure energy. Now, if you put a gram of antimatter or a large amount, say around the size of my hand, like this big, say this ball of antimatter, and you smash it against matter, you would get a huge explosion, probably enough to cover the earth. Because antimatter creates such amount of pure energy, and the amount of antimatter.
Actually, there's one problem with that. If it destroys one cork. Yeah, cork. If it destroys one, it will end the universe.
Not exactly.
Yes, it will.
Quarks
How much energy?
cannot be destroyed.
Yes, but there's probably something smaller than a quark that can be separated.
When you try to break a quark apart, they separate and make more. They just join together more.
They just bend.
Exactly. So if you want
They
to
act
take
like a cell.
Exactly. So it's sort of, but undestroyable.
Yes,
So-
like a normal cell.
So like, you have one. This is a quark, and you try to break it apart. What you're gonna do, if you have a bond of quarks here and you try to break it apart, what's gonna happen is that when they break apart, the bonds will break apart. Or bend, actually. They will
The
not
only
break.
way you could break it is by smashing it together. Smashing it to the point of no return. Making it into a artificial black hole. That will
So,
immediately absorb too many quarks at once, causing a hypernova.
A hypernova.
Due to just... When
A
you
hypernova-
smash a quark...
I mean a supernova.
No, a hypernova.
Hypernova is basically just a bunch of novas happening at the same time.
No, this thing's much worse. If a hypernova went off at the center of our universe, it could reach the distance of 3 of our galaxies, put side by side.
So, what is a
Annihilated.
hypernova? What is this question?
A hypernova, you take a supermassive star, like I'm talking 1 million bajillion times the size of Earth, and you smash it, and it will become a supermassive black hole, which can also produce a hypernova. Or it
So
will
hypernova
become-
is just a supersized supernova, you're assuming.
Yes, but it can be much more dangerous. We'll have to re-video it.
Where is that coming from?
Let's go over there. I need to go.
Okay, well, that's gonna be the end of the video until Baby Shark stops playing.